Hello guys, good day. This is Abelio here from IBM NZ. We are leading this initiative called IBM Systems Back to School. So the intent is to kind of summarize what should be presented in a full week during our face-to-face technical universities. So if Andrew, if you can just go a little bit further. Yep. So what is this all about? So we are in the third session of 8. So the idea is to show you, to highlight some topics that we feel like you will enjoy it, and any doubts that you have, just pop up on the question and answer. We are happy to answer those questions at the end, so we can have a bit of a discussion. The first session was about flash systems with Barry White. The second session was about power systems with Andrew G. Now Andrew G is back on stage to talk about how to boost your environment, your SAP HANA environment with IBM Power Systems. And stay tuned on the rest of the series. We still have 5 sessions to go apart from today. The registration link is available on the chat, I reckon. Barry just put it at the blog over there. So feel free to join in any sessions. Invite your colleagues. Let's make this a big event. This is intended to be for you, okay? Next one. So, well, I was here and I just disappear. That's very bad, right? So I'm sorry. I need to have the new joke. Sorry, guys. So, Andrew, the stage is yours.
Thank you. Okay, so I trust you, excuse me, can hear me okay? Building from last week's basically introduction or recap on power and some of the advantages, we decided to do a more specialized session on SAP HANA. This is the last thing I left you with last week. The more I learn about SAP HANA integration with IBM's Power Platform, the more I'm impressed. Genuinely no real competition out there from x86 vendors, and that's from a business in Australia, who shall remain anonymous. So briefly, the Power roadmap that we went through last week, you can see how over the period, and we've only gone from Power 5 through to Power 10, which is coming, was due this year, but probably next year now with the events happening around the world. So we've gone from SMT2 in 2004, all the way through to SMT8, which first appeared on the Power 8 systems and on the Power 9s. And we did, Power 7 did 4 SMT4, so 4 threads per clock cycle, or 4 instructions could be done. Intel is still hyper-threading, which is 2 threads simultaneously. So they're back still at the technology we left behind in 2004. Power 8, Power 9 are SMT8. So there's a lot more happening per clock cycle. Last week also I talked a bit about optimization, and we were talking last week predominantly more about serialized transactions, how we gain more if we speed up the slow parts of the operation. Don't concentrate on making necessarily the processing faster, because if you halve the time, double the speed of the processor, it only makes a small reduction overall, which is up here on this first line here. And if I double it again, in fact, I only make it half as much again. But if I speed up the red parts by improving my I/O, which is what we discussed quite a bit last week, then I can have a much greater effect on my transaction time. What I also covered last week was Mr. Armdale, IBM engineer, who is working on parallelization. Now, SAP HANA is a massively parallel in-memory database. So this is a very simplistic view of a parallelized transaction. So we have our bringing our data into the processor, and then we can do 8 threads at a time, and then we output the data, etc. So we can actually do a lot more work in the same time frame compared to an Intel, which could potentially do 2 of these boxes. So that's why we're just recovering that. So we had Moore's law with the doubling of the number of transistors. We had Amdahl's law on increasing parallelization, and has a huge effect on SAP HANA, the more things we can do at once. So we can do threads or processors. So here's our product range again, and on the left-hand side, we have the mission-critical workloads on the entry, mid-range, and enterprise systems. Note that the names are H922 and H924 are there, which are HANA-specific configurations. The machines over on the right-hand side, which are machine learning, deep learning, AI type boxes with a lower thread count, only 4. We don't use those for HANA. But HANA can work using what we call the TDI system. So we don't necessarily make an appliance, as do many of the x86 competitors. We actually put the right amount of CPUs, cores, memory, and storage and network from a customer's own thing under a TDI process, which is tailored data center infrastructure, I think it is. I should know that. So we have a couple of models here, the H922 and the H924. They were designed as a pricing artifact, really. It's the same physical box as a 922, and we just price it accordingly. And we also allow you to do on those boxes 25% of other shared workloads, non-HANA, so IBM I, AIX, anything else you want to do is done on those boxes as well. So we have systems in New Zealand across all of these platforms. We have the E980, a large retailer, input one last year. We've got the 950s, which is a 4-socket box. Each of these drawers on the 980 are 4 sockets, and we can put 4 drawers together or 4 nodes together to form a 16-socket beast of up to 64 terabytes of RAM. In the 950, we can do 16 terabytes of RAM on 4 sockets. So our density is far greater than the Intel platform. So these are the values that people say they have with IBM Power Systems and when running HANA. They can provision faster because with Power and Power VM, on top of it, we're able to react very quickly to different customer demands, and we can dynamically change, add, reduce memory, CPUs, etc. We need to be able to scale affordably, and this is really our strong point, how we can scale up, which is always preferred over scale out, especially for SAP's recommendations, and how we can do that far better than we can in an x86 environment. We talked last week also about maximizing uptime, the cost of downtime on an enterprise, and we'll cover that again later. And what we're seeing here is they provide rock solid reliability for our clients' mission critical SAP applications. So we talk about provisioning. So our largest scale up partition can be 24 terabytes, and it's 24 terabytes for S4 HANA, which is the OLTP system, and it's also 24 terabytes for Business Warehouse on HANA, their OLAP system. They have different processing and core requirements depending on the workloads. So HANA is a hybrid. It does both of them. So what we can see here is we've got a Power VM, our virtualization layer, and then we have multiple LPARs, logical partitions, sitting on top of them. We can partition another one of these very, very quickly. We can create templates, etc. And basically what we call push button. We also integrate to SAP's Llama, which is Landscape Manager. And so using the SAP Landscape Manager, we can deploy another LPAR very, very quickly. And you can see here what we've got on here. We've got ERP, systems 1 through 6, which is S4 HANA. We have Business Warehouse, and then we have CRM, which is a similar type of workload to the ERP system, not a business workload. So we're very granular in our capacity allocations. This is showing how we can, from scale out, in our small boxes. And what we can start off with, we can start off at 128 gig and 4 cores. We can do a granular allocation of 1 gig at a time, and then we can do 0.01 of a core. So our smallest LPAR that we can make on a power system is 0.05, 1/20th of a core. We have a requirement still pretty much from SAP to have a 4-core minimum on a system for production, although that can vary. As I say, we can scale up in a single platform to 24 terabytes. Now, our biggest scale up platform, as I said earlier, the E980, can scale to 64 terabytes in the one box. So what we can do, we can scale up to 24, and then we can scale out within the 64 box. So we can have scale out in a scale up platform, and we can scale out to theoretically 96 terabytes of S4 HANA using multiple modules, and we can scale out to, I can't remember, what BW256, there we go, 256 terabytes for Business Warehouse. When you compare that to the x86 and their virtualization on VMware, the largest 4-socket capacity, I believe, for S4 HANA is still 6 terabytes. Anything greater than 6 will need to be a bare metal install. And for Business Warehouse on HANA, the largest scale up, I believe, is still 3 terabytes. However, you can scale out by using 2 terabyte modules. So we'll see why this is important later, when the impact of BW. So theoretically, you could go to 32 terabytes and scale out with 16 2 terabyte nodes. So what we actually do is we provision the right amount of cores and the right amount of memory. We're not an appliance. You don't have to buy 4 sockets with 28 cores each at this processor type, and then that's your HANA solution. And it's, for argument's sake, 2 terabytes. What happens when our system goes to 2.2 terabytes? Do we have to replace the whole appliance? Sometimes yes. Other times you have to do what you call a mixed memory. So SAP generally certifies specific configurations, and uniform memory is always ideal and what they recommend. So if a customer needs to go from 2, they might have to go to 3.5 or something like that using mixed memory modules, which means if they grow again, they'll have to throw some memory away. With the IBM system, you allocate as little as 1 gig at a time, or 0.01 of a core we can add to make our workload exactly as we need it. So just to recap on logical partitions and processor pools, down the very bottom, you'll see we have 8 cores. IBM always starts at 1 unless it starts with 0 in our numbering convention, and we use both of them on this page. So we see here a shared pool of 4 cores. And then we have dedicated cores over on the right-hand side. Until August last year, the only way of running SAP HANA in production was using dedicated or dedicated donating cores. In August 2019, we announced that production could run in a shared processor pool, and we'll cover that in a little bit. So what we now do is look at LPAR number 1. We have 3 virtual processors, and we want 0.3 of a processor in entitlement. So what the system will do, it will equally slice 0.1, 0.1, 0.1 over each of the virtual processors. Remember, this is a shared pool of 4. LPAR 2 also has a requirement for 0.3 of a processor, but it only has 1 virtual processor. As you can see down here, each of these white boxes is 10%. Over on the right-hand side, the dedicated, right, the entire core is implicitly in there. So there are 4 cores with all of the capability. Even if they are 0.1 each, they've got the 100% of each core. So if you think about it, one of the messages we had from last week, if I can make my smallest LPAR generically a 20th of a core, and I can have a box with 20 cores in it, then I have 400 very tiny LPARs. We actually have our own cloud. Now, this can be on-prem, it could be in the cloud. Remember, cloud isn't a destination, it's a policy and framework. So you actually do, with the level of virtualization you have in your systems, you do actually have your own cloud. Even a single server is actually virtualized. Now, why is it important that we can use shared processor pools? So here, hopefully, you can see some animations. The pink boxes are more active than the generic green, and you'll see a section, hopefully, of lighter green coming out of the side. HANA is a very spiky workload. It's all on, nothing, all on, nothing. So what happens is, if each of these LPARs, each of these HANA databases or application servers have to be able to be sized to run the maximum capable workload, there are times, obviously, that it's not using all its processes, and those processes can't be shared. As I said, this was the case and for production environments until August last year. Development, test, QA could exist in shared LPARs, shared pools. So what we have here is, LPAR number 1 and LPAR number 4 are getting quite busy. So if we were to take these dedicated cores, and you can see the spare space off to the right of number 3 where I am now, occasionally it might get up there, but I'm wasting cores, I'm wasting performance. So what we can do is put it into a shared pool, and those 5 LPARs can work between themselves using all the allocation efficiently, and it may be that you don't need to allocate as many cores. So we're actually right-sizing our system. We can share them, it's simple to deploy, and it just takes and gives CPU as required. We can weight an LPAR and say this LPAR is more important than another, and so it would be harder for a different system to take spare cycles off that one. One of the other the tenets we looked at was maximizing uptime. And we covered this partly last week as part of the power advantages, saying that 88% of our customers now require 99.99% uptime for mission critical systems. That's actually up from 83% in 2019. And the source for this is the ITIC 2020 or 2019 Global Server Hardware and Server OS Reliability Survey. This, if for our partners and our IBM is on the call, is a very good document to have in your toolkit when discussing with customers. So 88% of those people estimate that an hour of downtime is greater than or equal to $300,000 an hour, which is roughly $5,000 a minute. That's up from 86% in 2019. IBM Power 8 and Power 9 systems, we exhibit less than 2 minutes per year unplanned, so $10,000 per annum. Some name brand x86 servers exhibited 26 minutes a year per server. That's $130,000 of lost opportunity or cost to the business. White boxes, up to 53 minutes per server, $260,000. And 34% of these people said their loss is greater than or equal to $1 million per hour. So when you're looking at systems, you need something highly available. We've got situations now that even for sales, but also for parts, moving parts around the world is becoming problematic at the moment with massive increases in airfare. And so we're starting to see people put things on ships as we used to in the old days. So if you can imagine having a server with a faulty hard drive and you need to get a new hard drive in country because they've gone, they run out, what's the lead time going to be for those things? You're certainly not going to put a hard drive on an airplane and fly it around the world to New Zealand. So this is a clip from the ITIC report in 2019, where you can see if you add up the 25, the 16, etc., it'll come up to about 86%. And you can see from 1 million up, we're seeing about 34% or so of people with a cost to their business. So how do we stay highly available? Because this is an in-memory database, everything in memory is basically a single point of failure. So we've got to try and keep these systems up, and power systems have amazing reliability, less than 2 minutes a year, unexpected downtime, so 99.999% availability. Other tools we can use to keep the systems or the applications available: live partition mobility, live application mobility, or partition availability priority, we can do that. and the x86 world can do some of these or support it or not. We have first failure data captures. So if there is a problem, then we capture information about it first time and put that into the error log so we can analyze it, etc. Processors in our enterprise systems, we have processor instruction retries, alternate processor recovery, dynamic processor deallocation. We can turn a processor off. If it starts to hit a threshold on too many errors, we can say, right, we'll pause all work to that one, slowly vacate it, and then turn that processor off. And if we have a spare processor, we can bring it back in. You can't do that in the Intel environment. Memory is important because it's an in-memory database. So again, on our bigger systems, the E950 and the 980, we have chip kill, we have spare modules on the memory arrays, and we can black out an entire memory chip if we needed to and carry on running. Double memory failures, yes, we can survive. We can certainly fix some single bits, etc. We can mirror selectively memory. So what this is talking about here is the hypervisor. So if you virtualize your system, you need to make sure that the unit that's running that is highly available. And so we actually selectively mirror some of the memory, just the hypervisor partial. Obviously, in the Intel environment or x86 environment, we can mirror the memory, but that costs you twice as much, and it also has a performance impact. So the RAS of an Intel platform or x86 platform is not as high as the power ones. For I/O, we have faster I/O buses, etc., which we covered last week. So, as I said, 99.999% availability. We've been ranked #1 in reliability for 12 consecutive years, along with the mainframe, which is probably slightly more reliable than we are. And we have zero impact planned maintenance with live partition mobility. So we can actually move a working HANA instance from one machine to another and then do maintenance work on. What we've also done is introduced a solution that other vendors have created a hardware solution for. So these are in-memory databases. Memory is relatively cheap, but you're talking terabytes, it does add up. And because we've said that the systems are less reliable than power systems, if they fail, then you've got to reload them. And reloading a system could take up to an hour, depending could be 40 minutes, 50 minutes, an hour, or more. So what they've actually done is you have the Intel Uptime, which is a persistent memory module, and you have to buy them and put them into, and you can only put them in the Cascade Lake system. So if you've got an older system of 2-3 years old, you cannot put the new Optane memory chips into it. You're going to have to get new systems to run and get this availability. So because the systems are falling over, they want to put the data into the memory and have it remain there, even if the power goes off. And IBM's chosen to do things slightly differently. So we introduced a thing called virtual persistent memory on IBM Power Systems. And we'll cover how it works in a little bit, but what we found is testing our own systems is we have a 17 times faster startup and we have a 30% faster shutdown. With an Intel system, the shutdown can actually increase in time, and that's because the Optane memory chips work about 10 times slower than the DRAM chips. So they're on the same memory buses, alternated across with DRAM and then persistent memory, but they're slower. So when you go to shut down, you're writing out 10 times slower than you would be into memory and going out disks. When you boot or restart, absolutely, it's there, it comes in faster, right? So you can actually increase the shutdown time by putting persistent memory into a machine. With IBM's, you don't, because we're still working with DRAM. This is a construct we've created using normal memory. There's nothing special about this, except a very clever way we do it. So what we do is in the hypervisor and the HMC, we define a system area we call it the main region, and we make that persistent. So if this was a 4 terabyte system, arguably we could do 512 of working memory and 3.5 terabytes of persistent memory. In IBM systems, if you fill up the persistent memory, it doesn't really matter. It just takes some more of the working memory. In an x86-based system, if you buy an insufficient amount of Optane memory, persistent memory, and you exceed it, I'm pretty sure your system's going to crash. So what we do is we write the data into the persistent memory. Obviously, the working region is still RAM as we know it, and everything works at the DRAM speed. The best thing about it is that we can actually restart the LPAR. We could restart the application, and that memory will remain, data will remain in the virtual persistent memory. The only thing that will cause it to go is if the server itself is powered off. So you might say, what's the cost to have these performance increases 17 times faster, 30% startups and 30% improvement on shutdown? Well, the interesting thing is there isn't one. It's free. IBM released this. As long as you have firmware 940 on any Power 9 platform, you can put virtual PMEM for SAP in. There are some other gotchas, like you have to be at the appropriate level of HMC code, you have to be using the appropriate level of SUSE. So we don't need to actually go and buy anything. We don't need to rip out all our Power 9 servers and replace them like you do with the Cascade Lakes. So we have a faster SAP HANA Restart. It improves the shutdown time. So depending who you're talking to, the business, it's maximizing your application uptime. To the engineers that are doing maintenance, gives you a slightly longer maintenance window. So there's a win-win situation. Preserves the runtime performance. As I said, the only way you're going to lose this is if the server is physically powered off. It's NUMA aware, so it's located to in reference to the processor and the core integration, and you continue to get faster insights, and it's enabled by virtualization. Therefore, we can change it on demand. So if we have changes between LPARs or just within an LPAR, we can do this. And as I say, it's available on all existing Power 9 based systems at no additional cost. That we think is a huge advantage and a system availability for SAP running on IBM Power Systems. How do we get faster insights? So we can typically do twice as much work per core than an x86 platform. We've got multiple benchmarks that have done this. The fine print will tell you that we've compared this against a 20-core system that we have. We're against 2 Intel Skylake Platinums, which are 224 cores at 2.7. And yeah, we can do twice as much work. So we generally get around about, in rough fingers, 6,000 SAPs per core. We have 1.8 times the memory bandwidth per socket. We'll just cover that a little bit. We covered that last week. And 2.6 times memory per socket over x86. So we actually need less infrastructure to run our solutions than we do in the x86 world. And these are quite dramatic advantages. So last week we covered the processor bandwidth within the processor. Then we started talking about memory bandwidth. So remember we have scale out servers. And so we do around about 170 gigabytes a second compared to an x86 platform of 128 gigs a second. So about 1.3 times the bandwidth. Using standard DRAMs, we can put 4 terabytes in a 2-socket system versus 3 terabytes in an x86 2-socket system. What does that mean? It means we don't need as much hardware. We don't need as many servers. 80% of the SAP instances across the world are sub 4 terabyte in capacity. So if we can do that in a 2U box, or even a 1U box, if we can put 4 terabytes there, and sorry, in a 2U box or a 4U box, not a 1, then we need less infrastructure. And we have a working example at the end of this talk on the typical rack space we use in an Intel environment versus a Power. Our scale-up servers, these are the ones, 230 gigs per socket, right? versus Intel's 128 gigs. So here's the 1.8. That's where the 1.8 comes from. So in our enterprise 950s and 980s, we have a lot more bandwidth from memory to CPU. Using buffered memory again, these are the cyclic redundancy checks, the chip kill, and the dynamic lane sparing. And of course, we can do 4 terabytes a socket versus 1.5 terabytes a socket in an x86 environment. Theoretically, we could go to 8 terabytes a socket architecturally. So at the moment, at 4 terabytes to 1.5, we're looking at 2.6 times the capacity. Virtual PMEM, we've just covered. No charge capability introduced with firmware 940. Oh, one last thing. I just noticed I made the color change and I nearly missed it again. So the scale-out servers, we do until the end of June have a twofer offer, shall we say. So talk to your geos. You can either buy 512 gig of RAM and only pay for 256. So that's an offer available in the scale-out servers only. And I think it's limited to the 32 gig increments. So just check with your geos to see if that's available. And it's available until the end of June. And what we also did to increase the I/O is we released NVMe PCI adapters. So we have 1.6, 3.2, and 6.4 terabyte capacities on these drives. So writing things to your log files or your data files, if this was in the server itself. These have no data protection. They don't have a SAS controller. So they're just a raw adapter. So you buy 2 and mirror them. And as luck would have it, until the end of June, again, there is a 2-for-1 offer on these, but just check your geo for availability and pricing. So SAP clients are rapidly adopting. So we've got over 2,500 clients now in under 48 months. We're ranked #1 in reliability, as we've talked about, for the last 12 years. We've got 50 or more cloud service providers or managed service providers using IBM POWER Systems for HANA. In 2018, we won the Pinnacle Award, POWER Systems, and in 2019, some of our partners have won Pinnacle Awards as well from SAP. There's a very good study by Forrester showing 137% ROI and 7 months payback, and we can provide those information to you, or if your IBM reps can. If you want any information in the questionnaire at the end of the session, just pop in there that you'd like a copy of the Forrester report and etc. So the largest scale-out capacity for S4 HANA and BW for HANA, 24 terabytes, compared to, as I said, 6 for a VMware 4-socket machine and 3 for a VMware or Business Warehouse. Again, this is just a highlight of the Forrester report, 1.7 million MPV, 137% ROI and 7-month payback. It's quite a good report to read. These are some of the customers that have taken the SAP Innovation Awards, Coop, which is Switzerland, and Toyota, etc. We can get case studies and information on these. We'll just do a little bit on Coop or Co-op. I don't know how they pronounce it in Switzerland. So operates, it's a supermarket brand, operates 2,200 supermarket branches. They need real-time insight into data inventory. They want to offer click and collect. They get 5 times quicker analytics with 85% fewer processor cores. They moved 300 SAP applications. So not just the HANA database, but the associated peripheral servers, the application servers, etc. And 20 times faster SAP HANA provisioning, driving innovation. So they can fire up another LPAR or another partition or another application server very, very quickly. Again, just reiterating, we're running 50 cloud service providers or MSPs. And the most important one probably is on the right-hand side, which is SAP is now using IBM POWER Systems in the HANA Enterprise Cloud that they offer. So SAP has embraced us, shall we say, or it's shows the value that IBM is bringing to the market. A lot of the rules that were put in place when we brought these offers out in 2015 were set by SAP. So we had the same core to memory ratio as an Intel or x86 platform had, and certainly wasn't taking advantage of the IBM performance but that was the supported by SAP configuration that people had to buy. So over time, those ratios have improved. It was like 1 to 32, I think 1 core to 32 gig. We're up to potentially up to 1 to 250, 300, 400 gig, depending on the application. And your SAP implementation partner will be able to run a wee routine on the system, which shows you how many SAPs your system will need, and if you are working in, say, units of 1 terabyte, how many of these you might need to deploy, etc. And it would also tell you whether your workload is a small workload, a medium or high workload. So it's possible to have the same thing on the same memory capacity. So you could have a 2 terabyte system that is actually a small workload, and so you don't need anywhere near as many cores to the memory. But if you've got the same 2 terabytes, but it's running a different version or different jobs on HANA, then it might be a high, and so you need a greater number of cores. So the sizing is very good, very granular, and not so easily achieved in a virtual environment with VMware. Again, we'll have more customer stories for you, and when we print this off, you should be able to click on the links and read their success stories. And these are the provision faster, scale affordably, maximize your uptime, the things we've covered today. So zero impact with planned maintenance with application mobility, virtual persistent memory for faster shutdown and restarts. Let's make those applications available. The most reliable server for over a decade, so 12 years actually now. We can minimize the infrastructure we need to buy. So we don't need to buy or allocate the number of cores that any LPAR would need to achieve at its maximum, and have it not achieve that most of the time by using the scale out. In fact, what we did, we ran some tests with a four cores dedicated system, and then we ran it with on an 8-core machine. We ran it with 4 cores, but we only said 4 virtual processors, but we only said we only want 3/4. So we're going to give you 3 terabytes that you're entitled to, and we didn't run anything on the other cores, but we said go, run. And what we found was that with the shared processor pools and the ability to take cycles as and when needed, there was only a 1% delta between dedicated cores and a system with 3 terabytes allocated, but being able to use 4 terabytes. So some very, very good work done around the virtualization and how we can scale. Just to sort of wind up, here's an example we did in New Zealand. The client wanted to implement 2 4 terabyte instances, one of BW and one of Suite on HANA, as it was at the time before S4 HANA came out. And the scale out, we had a choice of 1 terabyte or 2 terabyte. It's still 2 terabyte, x86 appliances. All appliances must be the same size. Therefore, any growth would require the same increment. The minimum quantity would be 3 units, 1 master and 2 workers. But then we'd want a high availability node, so that would be 4 nodes. For a 4 terabyte system, that's 4 1 terabyte nodes plus the hot spare, or 5 nodes. Or using 2 terabytes, we could go down to 4 nodes, although we've got 6 terabytes usable. So the client decided, we've got a production system, and we need a dev system, and a test system, and a DR system. And so that starts to add up. So for Suite on HANA, remember at the time we could do 4 terabytes in a single node, and using VMware now, that's 6 terabytes in a 4-socket. Plus 1 more, so we would basically have high availability. We have 2 boxes, and so 2 of those nodes would take up 16U, so the 8U each. So we need 56U for the production instance with 5 1 terabyte nodes plus 2 4 terabyte nodes for HANA. So over a rack, close to a rack and a half of space would be required in the data center with obviously the heating, the cooling, 10 gigabit network between the HANA appliances, because that was the minimum requirement. So if the customer didn't have it, they'd have to put a 10 gig network in. With IBM Power Systems, we were able to put in, we used a Power 8 in this day, but with Power 9 last year with another customer, based on 3 drawers and a total of 9 terabytes of memory in that. At the time, the maximum we could have put into 3 drawers would probably be about 12 anyway. So we have one control unit in the E880 and 980, which is 2U, and we had 3 nodes at 5U for a grand total of 17U. So it's a reduction in 70% in rack space. And that saved also hundreds of thousands of dollars in increasing the computer room size that they needed, probably close to $500,000 they saved by not putting x86 appliances in and taking up that 56U. So what's next? Go and have a look at ibm.com/SAP HANA. Clients and prospects, talk to your IBM sales execs. Contact us or your geography client technical architects for support. We have some splendid support in Australia. And that's it. A very quick one tonight, hopefully, 40 minutes. And here's the team. If we can help you at all, just get in touch. Thank you very much for paying attention.
We have 2 questions here.
Yeah.
So there, does persistent memory help you with the LPM?
With the
LPM, the partition
mobility? It doesn't. I don't believe it would help, nor would it hinder. All it does is, see, when you do an LPM, you copy everything that's in memory from one server across to another. The fact that it's not on Uptime means that it's going to transfer faster. So if you're trying to use something in VMware to move from a VM from one platform to another, then that would be potentially slower because the Optanes wouldn't be able to write out as fast and read in as fast at the other end. So it doesn't help per se because it's all working at DRAM speed. It just means basically if you've got a 4 terabyte HANA database now or 4 terabyte memory subsystem and you allocate 4 terabytes of working memory, what we're saying is maybe you only need a 3-to-1 ratio of that or 4-to-1 ratio. And say maybe just do 512. I think the instance that they said the 17 times speed up was going from 4 fully allocated to 512 working and 3.5 terabytes of persistent. And they did the same shutdowns and startups and compared them and got the 17 times improvement. So that's where it is. There's nothing to buy.
Okay. Is there an impact on to LPM? It is
LPM? Yeah. No, I wouldn't think so because, as I say, everything is working at DRAM speed. So all you're doing is presenting. Almost a virtual disk, as it were, in memory, and saying write this data and keep it here, right, electronically. It's working at normal memory speed, so there's no performance impact.
Okay.
As far as I'm aware, if anybody of my Australian colleagues, I can certainly go and ask that question, but it's relatively new. There is a very good paper which we can give like a primer or primer, depending where you come from, on virtual PMEM. More than happy to pull that down and distribute it to whoever's asking the question, or if anybody again in the questionnaire at the end of the system say you want some of the information, maybe you want the Forrester report. I think there's an IDC report, certainly the primer and the explanation on virtual PMEM and what you need to implement it and how you implement it. Oh, let me just tell you one thing about it as well. We have 7 conditions to follow when we do virtual PMEM. Like must be a Power 9 box. Oh, yeah, okay. I can't remember what the others are. They're really few. To do the same thing on Optane, there are 57 parameters that you have to check. So the first thing is it a Cascade Lake? No, can't do it. So we've got systems that are 3 years old, Power 9 systems out there that can implement this tomorrow.
Okay. I reckon that one thing that is important to highlight, Andrew, is the process that is built in when we do a SAP HANA project, right? So it is a bit different from other workloads, right? So we have, as SAP HANA considered as a certified solution, there are several steps to do a proper sizing, compare the amount of SAPs that is required, and then go to how much compute is required, and then go to my bit, which is the storage that is required. So we have all the steps by step that we need to follow in order to have this certification. So is pretty serious, right? And the result is just like Andrew was showing, right? So
Yeah, to build on that, Abilio, when you buy an Intel appliance, remember it's just the HANA database, effectively. If you wanted to virtualize that and run non-HANA workloads in it, then SAP's recommendation is that you run it on a completely different socket. So now you have to start putting processor affinity in, and depending which forum you may read, they'll say I wouldn't use affinity in production. So, and you have to do your affinity, I think, in half, 1 or 2 full cores. And there was not, as of last year, I'm not sure, I don't believe there is an SAP certified solution for greater than 4 sockets using VMware. So that's why we're still capped at, I believe, 6 terabytes is the maximum they can run on a 4-socket box. Anything greater than that has to be a bare metal. And some partners don't have an 8-socket box of their own making. Some partner with others and bring them in. But as you say, the ideal thing to do is to work with your SAP partner and have them run the scripts or the WE tools, and we can provide the SAP notes for you if you want to know what those numbers are. And there's different ones, whether it's for S4 or for BW. And you say, for example, hey, I think I'm this big, maybe I'll use a 1 terabyte node, and it will go out there, interrogates your system, and it comes back and says, yes, you need 1 terabytes of HANA database, therefore your machine needs to be 2 terabytes. You always have double the size of the HANA database, and you need this many SAPs. So then we can, and it's a small workload. So then we can correlate that with information we've got out of the special team in Germany, and we'll say, right, for this, there are X many SAPs per core. You need 4 cores, 6 cores, 8 cores, 2 cores, whatever it might be for that workload. And that's a production thing. So what we have with the TDI, we then run a script effectively and it says, does this meet all SAP's requirements? Whereas in the appliance side of the business, that's a certified solution by SAP. It is this processor, this model, this number of them, this number of this size and this part number memory DIMMs. It's very, very prescriptive. Whereas TDI, you can actually get quite clever and use your existing storage, use your existing network. So in some cases, we go out to some flash storage for the logs and maybe some SSDs for the data files that we do. Of course, if you wanted to make like a small system, because we can virtualize a 12-way or more cores in our systems, in our S924s, we can actually run the HANA database in there. We run the application servers in there as well. And this is what we do now, and we've sold 4 950s to a client here in the South Island of New Zealand for 2 different SAP HANA instances, and one being a national CRM database, and the other one, I forget, SAP CAR database that they put in there. And those boxes we have capacity on demand on them. So for example, we have 44 cores in the system, and we've only activated 33 of them, or even 22 of them. We may have 6 or 8 terabytes of RAM, and we've only activated 5, I think, in this case. So the client has got dark resources there. They can activate those as they require them and get an exact requirement, exact system for what their needs are.
Okay, that's brilliant. Well, is flexible, right? So, guys, any other questions? So you're seeing on the screen that you have all our contacts over there. So feel free to just check any question that you possibly need. Andrew, last comments. Otherwise, I will wrap up. Maybe Ben, if you want to talk. So that's the time. If not, we can wrap up the session.
Just going to say thanks to Daryl for pointing out that when I made the template, master for this. I got my own blog URL address wrong.
It was a deliberate mistake, Barry. Yes,
Yeah,
the guy gets a
it should be-
chocolate fish. Thank you,
It should
Darryl.
be .blog, not .com. So I've updated the master template, but thanks for pointing that out.
Yeah, we'll fix
Awesome, awesome. Thanks for
Hey,
that.
thank you very much for attending.
Yeah. So about that, so we just updated one last thing on the blog. So now it is much easier to register, to view the replays, to download the material, right? So we put everything under the same link. So you go to Barry's blog / back to school. You will see that there are the registration links. You will see also the box folder where we are keeping the presentations at the time that they are being done, right? So Andrew G's SAP HANA presentation will be available like in the next hours. And also the replay. I'm already putting a pressure on Andrew. So, but don't worry, it will be there at some stage. At some stage, it will be there. Just go for it. And don't forget that in the same page you will have the registration link for the following sessions, right? So we still have 5 sessions on these series. So please feel free to join us. Just one last message: don't forget to do the survey. It is really important to us to see how we are going, and of course we need to tell our managers that we are doing a very good job here. So let us know how we are doing, and anything that you want to see the next session. We are kind of doing this as a agile type of development. So if we do something wrong, we fix it for the next week. So feel free to reach us, any one of us, to say how we are going. Really do that. That's it. Today was easy, right? So thanks, guys. See you next week. Next week we will have Barry White on stage and myself as well, talking about troubleshooting, which is something that we have passion about it. So don't miss it. That will be very fun, and hope that you can learn something from it. Kia kaha, matewa. See you next week. Bye-bye.
Cheers, guys. Thank you, Sean, for answering the questions.